Advanced Math Lesson 63, Circles and Completing the Square. So we're actually going to learn how to graph circles and then how to come up with the standard form of the equation of a circle. You should be familiar with this form of a circle because we've been writing these equations in our homework. It's been on a couple of tests now. So the standard equation of the circle is this: x minus h squared plus y minus k squared equals radius squared. In this formula, the points h comma k would equal the center of the circle, and r obviously equals the radius of the circle. So let's give you guys a problem, and then we'll start off on how to complete the square, which none of the steps to complete the square change. It's just a little bit tricky because we end up doing two of them at the same time. I'll show you in a second as soon as I get my example down on paper. So this is our equation, and the book will tell you, this is the equation of a circle. We need you to complete the square to write it in standard form and then graph the circle. So right now, this equation is not solved. It's not in standard form. We have to use complete the square. What makes this a little tricky, it's not hard, but a little bit tricky, is we actually have to do complete the square twice on two different quadratics, all in one equation. Now the first step isn't going to change at all for complete the square. We're going to take the one whole number. We're going to move it to the right side of the equation. So we'll go ahead and do that. We'll add 11. All right, and then we've got 11 on the right side of the equation. Now, at the same time I do that, what I'm going to do is I'm going to group the x's and the y's, and this is where the double complete the square comes in. So I'm going to have one group, which is y squared minus 6y plus blank, and that is going to be added to x squared plus 8x plus blank. So what we see here is we're doing complete the square with the x terms separated in parentheses and then added to the y terms separated in parentheses. So we'll do complete the square on both of these quadratics, add both the values in each blank, and then on the right side we'll add both of the blank values. We'll see that in a second in case you're not a verbal learner. So let's start with complete the square on the x. We'll only do the x first, and we'll do this in orange. So we're going to take this 8, right, and we're going to divide it by 2 and then square it. Right? 8 divided by 2 is 4. 4 squared is 16. So we add 16 to this side, and then with complete the square we'd add 16 to the right side as well. Right? So we just did complete the square there. Now, on the y, we're going to do the same thing. We're going to take this coefficient -6. We'll divide it by 2, and then square it. When we divide it by 2, we get -3 squared gives me +9. So I add 9 to the y, and then I'm also going to add 9 to the right side. So that keeps the equation equal. From here, I've got two perfectly squared quadratics, and then I've got some whole numbers I need to simplify on the right side, and then I can keep going into solving, or rewriting actually. Let's go with green. So 11 plus 16, I get 27. 27 plus 9 gives me 36. So I've got 36 on the right. And then here, I'm going to go ahead and factor these into their perfect squares. And we'll remember that the x is going to factor into this number right here, so it's going to be x plus 4 squared. And then here, the y is going to factor into this term here, so we're going to have y minus 3 squared. Now, our equation is almost in standard form. The only problem here, so we've got the x minus h, we've got the squareds, we've got the y minus k, we've got the squareds. The only problem is we don't have radius. So if radius squared, we can do this as a mini equation. If up here radius squared is equal to 36, then what is the radius equal to? So for this, the last step is we would take this number, find the square root of it, which is going to be 6. Lucky for us, that was a perfect square. And then we're going to square it. Right? So this seems a little weird, like why would you take 36 and then write 6 squared? It's the same reason why in your homework, whenever I read the answer off, I can say you can write, all of this equals 36, or you can write it equals 6 squared. The standard form says that it will be r squared, so that way you can quickly see the radius. But if you write 36, I understand that's the same number. But you have to understand, in order to get this in proper standard form, you have to find the square root of this and then square that itself. So the final version of this equation is going to be x plus 4 squared plus y minus 3 squared equals 6 squared. And then it is finally in this standard form right here. And we know exactly what the radius is. The radius is 6. Now when it comes to graphing this, remember I said that h comma k is the center of the circle. And then these are also subtractions. So whatever this value is for h or k, we have to use the opposite sign. So if this is positive 4, then the h value is actually negative 4. If this is negative 3, then the y value, or the k value, is actually positive 3. So that is our center. 6 is our radius. And we graph it just as easy as this. I'm not even going to use the coordinate plane that I have because it's not going to come out right anyway. Or not right, but perfect. It's not going to come out perfect. So first I'm going to find the center of the circle. I'm going to go negative 1, 2, 3, 4, positive 3, 1, 2, 3. That is the center of my circle. And then, get this, to graph the circle, I'm just going to draw a line. I'm going to say that that is 6, and then I'll draw the circle. Circle complete. So when it comes to graphing your radius, you just kind of draw the line and guesstimate the size. It's not going to be perfect. If you want a perfect size circle, you can go and punch this equation into your graphing calculator and see what it turns up. But again, most of our graphs are just going to be sketches, so that I know you guys are understanding the concept and so you can quickly visualize what shape the function is creating on the graph. Actually, this isn't a function, this is a relation since it's a circle. Anyways, that's it for this lesson. That's how you do complete the square and graph a circle on a coordinate plane. If you have any questions, let me know on Moodle, and I will see you in class.